We had to eat it for making up snow days, so 12. But we don't carry over to the following week, which is really good.
Do I have to be in your science or academic tutoring?
Uh-huh.
Well, that means football. Does football get delayed then because of snow days?
Yeah, you're smart.
Football? What does football have to do with snow days?
Intelligent?
Yeah.
Why would our snow days this year affect next year? It just extends our school year.
All right, here we go. Okay, let's get our notes out. Here we go. Today we're talking about arc lengths, and we did circles, the circumference and area of circles at the beginning. And so if you'll remember that we had the formula for area, pi r squared, and we had the formula for circumference. And circumference was the distance around the circle. So I think someone said if you cut the circle and stretch it out, that's what circumference is. It's how long the distance around the circle is. So today we're talking about arc lengths, and so we want to be able to find the arc length. And here you have a little picture of a circle here. We have the arc length right here. It's a fraction, a portion of the circumference, okay? And we just want this little bit. We don't want the whole circumference. We want this little portion of the circumference. So that is the L for arc length. And then what you'll notice here in our circle is that we have x degrees. That's the measure of the central angle here. And we have the radius of our circle. And if we know those things, then we can really easily figure out the arc length of the circle, or the arc length that we have highlighted here. So as I said, the length of an arc is, so the length of the arc, L, equals a fraction of its circumference. So we're going to have some fraction here. And then what is the formula for circumference?
C.
2 squared r.
2 pi r. Very good. Circumference is 2 pi r. So we're going to have some fraction of circumference, which is 2 pi r. And the fraction is how many degrees that we want. So we have x degrees. Well, that's the part that we want. What are the total degrees that we could have? 360, exactly. So that's the fraction, 360 degrees. So x degrees over 360 degrees times 2 pi r. Super simple. That is the length L. So we want to find the length of each bolded arc to the nearest hundredth. So you get to use your calculator, it looks like. So here is the length of this arc, that bolded arc that we're looking for. So L equals our fraction. What's our fraction?
C equals 2 pi r.
What's the fraction?
107.
107 degrees over 360 degrees times circumference, which is 2 pi r. And what is our radius? 6. So 2 pi r, or 2 times pi times 6. So all these things are multiplied together. And you can go ahead and plug that into your calculators. So my fraction is 107 out of 360 times 2 times pi times 6. And that's what I'm typing in. Nope, didn't mean to type in the negative. There we go. And I get 11 point, rounded to the nearest hundredth. What do I get?
11.21.
All right. And the length here that we're talking about is meters on this particular problem. All right, let's look at number 3. Again, we want this whole bolded arc right here. This whole, a big arc here. That's a large fraction. So that L there, L equals what fraction are we looking at for this particular arc?
4 over 360.
218 over 360. How'd you get 218? Yeah, I need this angle of this central angle right here. The other side is 142. So 360 minus 142 is, as you said, 218. So 218 degrees, that's our corresponding central angle. So 218 degrees out of 360 degrees times 2 times pi times radius. The radius is 4. All right, plug that into your calculators, please. Plug that into your calculator. Tell me what you get. .22, and we're talking centimeters here. Very good. I did a little approximation squiggles that I did backwards. Looks weird. All right. I don't know. Okay. Great. 15.22. Super. Let's look at number 5. It says EB, so again, reading carefully, EB is 15 centimeters. That is our radius of our circle. Find the length of arc CD. We want to know this arc right here, so really pay attention to what we're figuring out. This is the L I'm trying to find, that length of the arc. What do we need to know? Arc DC corresponding angle, yeah. Angle CED would be good. I'd like to know that pink angle there. How do we figure that out? 180. Good. 180 minus 68 gives us 112. So this is 112 degrees. How did we know it was 180 minus? Diameter. Very good. We have that big long diameter there. And so very good. We can just subtract from 180. All right. So to find L, we have a fraction, which is what out of what? 112. Good. Times 2 times pi times r, which is 15. Excellent, excellent. Do we need to do the calculator work on that, or you're good with the calculator work? Okay, all right, great. Super. Let's turn the page. Let's look at number 9, I guess. Let's look at number 9. Let's see, it says FG is 27 yards, so this is a diameter, a radius there. FG is 27 yards. We want to find the length of arc FED. FED, that is this arc passing through E and ending at D. We want to find that whole arc there. All right, so there's our L we're trying to find, the length of that whole arc. So I need to know, what is my whole corresponding angle there? Well, how can we figure out that whole angle? Oh, wait, that one's 90. Yeah, that one is 90. So yes, we can subtract them all from 360. That would give me the G part. I think what I'm going to do is I'm going to do 360, minus 47 minus the 80. That's really all I need to do. If I take away the 47 and take away the 80, that'll leave me with this pink whole thing, which is 233 degrees. Okay. So then my length is some fraction 233 degrees out of 360 degrees times 2 times pi times my radius of 27. Because that was my radius right there, was FG. Okay, any questions on that? Super easy, huh? Let's look at number 11. A 16-inch pendulum. What's a pendulum?
It goes back and forth.
That's the thing that swings back and forth like my robot arm? Okay. All right, so we have a 16-inch pendulum, and so there is the 16 inches. It sort of acts like the radius, if you will, okay? Swings through an angle of 40 degrees. So what we have here is this lovely little 40-degree angle. And you can imagine that that is swinging part, if it went all the way around, it would be a portion of a circle. So if we want to know how far does the tip of the pendulum travel in a single swing, then this is really simply asking a question of what is the length of the arc that it travels here. So what is this length L, that fraction of a circle? So again, L is simply a fraction of the circumference, 2 times pi times our radius. What is our radius? 16 inches. And our fraction? 40 over 360. Good. So really not too terrible there. All right, and number 12 is a little bit different. A car entered a roundabout from Mason Avenue. So do you guys know like a roundabout? Yeah? Okay. So it's sort of a circle, right? Entered a roundabout from Mason Avenue and traveled 280 feet and then turned onto Perry Street. If the roundabout has a diameter, so maybe it looks something like this. So here's Mason Avenue and traveled 280 feet and turned onto Perry Street. I have no idea what this looks like, but I'm just guessing. I sort of know what a roundabout is. But you can imagine it's a part of a circle. If the roundabout has a diameter, of 150 feet, I don't really care about diameters. Tell me about the radius. It's what? So the diameter is 150 feet. What's the radius? 75. There you go. Okay. So 75 feet. So the radius is 75 feet. Find the angle of rotation. Here we're finding the angle of rotation. And, well, that's kind of interesting. It traveled 280 feet. That would be this whole distance around. So we're actually on this particular one, they're giving us the 280 feet. They're giving us the arc length. And we need to figure out, hey, what is the angle of rotation? So if we wanted to know that, we'd need to know this whole angle right here, which I don't necessarily know. Like this look, I drew a right angle, but it might not be, right? It could be anything. So I'm going to set it up just like I was before, where we had L equals some fraction times 2 times pi times our R value. But what else do we know? What was L? 280, yeah, that is our 280 feet that we traveled around the circle on our little roundabout. And the angle of rotation, that's x that we're trying to figure out. So that is x over 360. That's what we have to figure out, what is x. So I'm going to do a little bit of cleanup here. Let's see, I have 280 equals, let's see, I have 2 times 75, which is 150. So that's 150 pi times x, all divided by 360. Do you guys have any questions on how I got that? Okay. Right now it's being divided by 360. What can I do with that 360?
You divide it on both sides.
Divide it. It's already divided.
On both sides.
Multiply. Yeah, I'm going to multiply by 360 on both sides because that'll get rid of it. All right. And so, I don't know what that is. So, 360 times 280 feet, I'm going to write it over here, is 100,800 equals 150 pi times x. All right, how do we get the x by itself? Yeah, we want the x, I want to get rid of the other things, so we have to divide by 150 pi. This is really hard to do in our calculators, it turns out. So I'm going to encourage you to, we want to divide by both things. So the one thing that you can do is put parentheses around it. That divides by the whole thing. All right? The other thing you can do is use your alpha, press alpha F1, and get the fraction thing. And so if you use the actual fraction in that form, it'll work as well. But watch what happens. Here's the answer. So 100,800 divided by parentheses 150 pi. So there's our answer. So x equals 213. 214. They want it to the nearest degree. So 214 degrees approximately. Okay. If you did 100,800 divided by 150 pi, you'll notice we do not get the same answer. Very different answer there. And that's super important. This is the #1 mistake on calculators. What your calculator is doing is it does order of operations. It does exactly what you tell it to do. So what it's doing is it's taking our 100,800 and it's dividing it by 150, and then it's multiplying it by pi. That's exactly what you told it to do, all right? The difference is when we put parentheses around, it's saying, hey, divide by the entire group now. Okay, so big difference mathematically, and really important that you understand that. So this is a good little practice there. So make sure you use parentheses when you're dividing by more than one thing. Okay. Do you have questions for me? Super. Under 20 minutes, you guys.